Swayam Prabha. Digital India. Educated India.
Welcome back. So, in the last lecture we were seeing or we are discussing about the CU test, and we concluded that CU test is more versatile in nature, because CU test is faster as compared to the CD test, as well as from CU test whatever you will be getting, whatever results you will be getting, you can also get that result from CD test. So, therefore, if you perform CU test, you will be getting both the representation with respect to the total stress, representation with respect to the effective stress, right. Now, at failure, okay, in case of consolidated undrained test, at failure A bar is nothing but A bar is equal to delta UDF by delta sigma dF, where delta UDF is the pore water pressure developed at the failure and delta sigma dF is the deviatoric stress at failure, right. So, for normally consolidated clay, generally AF varies from 0.5 to 1. That means, if it is 1, that means the pore water pressure is basically equal to the total, the deviatoric stress, right. So, it generally varies from 0.5 to 1, whereas in case of over consolidated clay, A varies from minus 0.5 to 0. Why minus 0.5? Because you are getting the negative pore water pressure, if you recall, right, in case of dense sand or in case of over consolidated clay, right. So, in case of normally consolidated clay and the loose sand will be coming in the one set, and over consolidated clay and dense sand will be coming in the one set. Now, in case of over consolidated clay, basically A bar will be coming as negative. Why? Because your pore water pressure, that means your numerator is becoming negative, right. Negative pore water pressure you are getting due to the dilation of the material. Now, coming to the third type of triaxial test, that is unconsolidated undrained test, that is known as UU test. So, in UU test, drainage from the soil specimen is not permitted during the application of sigma 3 as well as delta sigma d. Now, what does it mean? So, in case of CD test, you allowed drainage, okay, you allowed consolidation when you applied sigma 3, that means cell pressure, and when you applied delta sigma d, that is deviatoric stress. So, there are two parts in which basically, in case of in any triaxial test, basically you have two steps. In one step, you first apply the cell pressure, and another step you shear it with the help of delta sigma d, that is the deviatoric stress. Now, when you are applying the cell pressure, in case of CD test, when you are applying the cell pressure, when you are applying the shearing, deviatoric stress, in both the situations you allowed drainage, right, you allowed consolidation, right, in case of first step, and you allow drainage when you sheared it. Now, in case of CU test, that is consolidated undrained test, in that situation you allow drainage, okay, when you applied sigma 3, but you did not allow drainage when you shear it with the help of delta sigma d, that is deviatoric stress, right. But in case of UU test, in no case, in no situation, in no steps, right, you are allowing drainage. So, that means drainage from soil specimen is not permitted during the application of sigma 3, that is in the first step, as well as delta sigma d, that is happening in the second step. Okay. So, the total pressure, the total pore water pressure U in the specimen at any stage of deviatoric stress application is nothing but UC plus delta UD, right. Now, two distinct, basically you will be getting the pore pressure generation in two steps. In the first step, you are applying the cell pressure, at that time you will be getting some generation of the pore pressure, and in the second step, when you are shearing it, when you are applying the axial deviatoric stress, at that time also you will be generating the pore water pressure. So, that will be coming in the second step. So, in both the steps, whatever pore water pressure you will be getting or you will be generating, that will be the total pore water pressure at any point of time, right. So, total pore water pressure U is nothing but UC plus delta UD, where UC is pore pressure increase due to sigma 3, that is happening in the first step, and delta UD is pore pressure increase due to delta sigma d, that is happening in the second step. Okay. Now, earlier we know that UC, if you recall whatever we have discussed in case of CD test, at that time UC was equal to B into sigma 3, right, okay, and delta UD is equal to A bar into delta sigma D, that is coming from CU test. So, this is coming from CD test. So, B is the Skempton pore pressure parameter and this is coming from your CU test, that is again A bar is your Skempton pore pressure parameter. So, therefore, U is nothing but B sigma 3 plus A bar delta sigma D, which is equal to B sigma 3 plus A bar into sigma 1 minus sigma 3. What is delta sigma D? Delta sigma D is the debitory stress, that means the difference between the major principal stress and minor principal stress. So, sigma 1 minus sigma 3 is coming into the picture. So, this equation 5.17 is very very important. So, that I mean if you know the pore pressure Skempton pore pressure parameters, basically you can calculate the total pore pressure developed during the test. Okay. So, this test is usually conducted on saturated clay and sealed specimens. Okay. Generally for saturated clay and sealed specimens, this UU test is conducted. The added axial stress at failure, that is delta sigma D F, is practically same regardless of the chamber confining pressure. So, we will see that. So, basically the thing is that sigma 1 minus sigma 3 is nothing but delta sigma D, right, agreed. Sigma 1 minus sigma 3, that is the difference between the major and minor principal stress, is nothing but a delta sigma D. So, at failure basically the whatever sigma 1 you are getting, that is the major principal stress, and whatever sigma 3 is constant during the test, right. So, the difference between the major and minor principal stress at failure is nothing but delta sigma D, and that will be remaining same, okay, regardless of the chamber confining pressure. Whatever confining pressure you consider, as you go on increasing the chamber confining pressure, and automatically your sigma 1 will be also increasing, right, at the failure. So, whatever you do, your difference between these two will be remaining same. Okay. So, we will see that. Now, this is a typical say plot for shear stress versus normal stress in case of unconsolidated undrained test. Here you can see. So, these are all total stress Mohr circles at failure. Okay. So, this is I mean you are doing the test at I mean in the same specimen, but at different confining pressure, right. So, this is one circle, this is another Mohr circle, this is another Mohr circle. In every situation what you are doing? You are just doing the test, performing the test at different confining pressure, at different cell pressure, right. So, if you consider this is your one cell pressure, basically you are getting the failure when it is sigma 1 is the major principal stress. Similarly, this is your modified cell pressure, you will be getting the failure at I mean you will be getting the failure for this major principal stress, whereas when your cell pressure is here, you will be getting the failure for this major principal stress sigma 1, and therefore, I mean in all the situations, in all the case, if you look at, so sigma 1 minus sigma 3 is nothing but your delta sigma D F, right. The difference is remaining same. Therefore, you will be getting one horizontal failure envelope where phi equal to 0, and you will be getting some intercept at the y axis, that is the shear stress axis, and that is nothing but your cohesion. Okay. So, therefore, we get tau f equal to C, only cohesion is equal to Cu, where Cu is the undrained shear strength and is equal to the radius of the Mohr circle. As you have seen from this figure, Cu is nothing but the radius of the Mohr circle. This is your radius. Okay. If you look at this figure, basically in this figure what we are doing, we are doing the UU test in a similar type of soil in two different specimens. Say one specimen is experiencing this much of cell pressure, another specimen is experiencing this much of cell pressure, and basically you are going to find out the effective stress Mohr circle. The effective stress Mohr circle is this, and we will see that your effective stress Mohr circle will be the unique, whereas your total stress Mohr circle could be anything. So, if you perform say n number of tests, you will be getting n number of total stress Mohr circles, okay, at failure, but you will be getting the unique effective stress Mohr cycle for UU test. We will see that. Now, what is the reason for obtaining same added axial stress delta sigma df? What is the reason? I mean, already we have told that sigma 1 minus sigma 3 is always becoming delta sigma df, and that will be regardless of whatever say confining pressure you are considering, that difference between the major and minor principal stress will be always delta sigma df. Why? What is the reason behind that? So, if a clay specimen, say number 1 clay specimen is consolidated at a chamber pressure sigma 3 and then shear to failure without drainage, okay, the total stress conditions at failure can be represented by Mohr cycle P, right. So, what we are doing here, if a clay specimen, so we are considering one soil specimen, clay soil specimen, that is number 1 soil specimen is consolidated at a chamber pressure sigma 3 and then shear to failure without drainage, okay. That means we are doing some CU test kind of thing, okay. Drainage, the total stress conditions at failure can be represented by the Mohr cycle P. So, this is the Mohr cycle which will be representing that condition, okay, the total stress condition. The pore pressure developed in the specimen at failure equal to delta UDF, as we have discussed, as we have seen in case of your consolidated undrained test, right. So, there basically we consolidated the material at chamber pressure sigma 3, but we did not allow the drainage during the shearing, right. So, at that time the pore pressure developed in the specimen at failure was equal to delta UDF, agreed, if you recall your CU test, okay. Now, thus the major and minor principal effective stress at failure are sigma 1 prime is equal to sigma 3 plus delta sigma df minus delta UDF. So, sigma 3 plus delta sigma df is nothing but the total sigma 1, right, that is the major principal stress, total major principal stress, minus the pore water pressure which is getting developed at the failure. So, sigma 1 minus delta UDF, okay, is your sigma 1 prime, whereas sigma 3 prime is nothing but sigma 3 minus delta UDF, agreed, already we have discussed this. So, circle Q is the effective stress Mohr cycle. So, this is the circle which will be representing the effective stress Mohr cycle, if you see that. So, basically you had sigma 3 here, now this sigma 3 minus this will give you sigma 3 prime, right, sigma 3 minus delta UDF will give you sigma 3 prime, whereas this was your sigma 1. So, sigma 1 minus delta UDF will give you sigma 1 prime. So, this circle is basically your effective stress Mohr cycle, right. Now, let us consider another similar specimen. Similar specimen means similar type of soil and similar specimen we are considering, and we are denoting, we are representing that specimen is number 2, okay. And for that I mean, let us consider this another similar specimen that has been consolidated under sigma 3 with initial pore pressure equal to 0, right. So, we can do that. So, we are doing this, okay. If the chamber pressure is increased by delta sigma 3. So, at sigma 3 we are applying sigma 3 and then we are allowing the consolidation and we are allowing the pore pressure is becoming 0. So, with that situation we are starting, and then what we are doing, we are increasing delta sigma 3, that is the cell pressure we are increasing, okay, without considering the drainage. So, if the chamber pressure is increased by delta sigma 3 without drainage, the pore pressure increase is equal to delta UC, and that is happening actually during the first step, right, when you are dealing with the only cell pressure or the confining pressure. So, delta UC is equal to delta sigma 3, because whatever additional I mean cell pressure you are applying, the same amount will be transferred to the pore water, because you are not allowing the drainage. So, soil particles will not take care of any kind of load, extra load, right. So, everything will be taken care of by the water itself, pore fluid. So, delta UC is equal to delta sigma 3. So, at this time effective confining pressure is sigma 3 plus delta sigma 3 minus delta UC, right. So, what is your total confining pressure? Sigma 3 plus delta sigma 3, and what is your effective confining pressure? Delta 3 sigma 3 plus delta sigma 3 minus the pore water pressure. So, pore water pressure is how much? Delta UC. Again delta UC is nothing but equal to delta sigma 3. So, you will be getting sigma 3, right. So, at this time your effective confining pressure is nothing but your sigma 3, right. So, same as specimen number 1. Okay. Okay. So, in case of this thing whatever we have discussed. So, hence if the specimen number 2 is sheared without drainage. So, basically now you are getting the same kind of condition, that is in case of previous slide, if you look at the effective confining pressure was sigma 3, right, and which was same as for specimen number 1. So, therefore, if the specimen number 2 is sheared without drainage, right, without drainage we are shearing it, it should fail at the same deviatoric stress, because I mean basically what you are doing, you are taking different samples from the same soil. So, it will exhibit similar kind of nature. So, it should fail, the failure should happen at the same deviatoric stress that was obtained for specimen number 1. So, the total stress Mohr circle will be R. So, this is your total stress Mohr circle for the specimen number 2. So, at failure minor principal effective stress was sigma 3 plus delta sigma 3, that was the enhanced confining pressure, minus UC minus UDF. So, why minus delta UC? So, why minus delta UC? So, that means this part is getting developed when you increase the confining pressure from sigma 3 to delta sigma 3, right. You did not allow the drainage, so it has been developed. Okay. Now, you did not allow the drainage during shearing also. So, therefore, at failure delta UDF has been developed, right. So, ultimately you will be getting, so this delta UC is nothing but delta sigma 3, right, already we have seen. So, you are getting sigma 3 minus delta UDF, which is nothing but your sigma 3 prime, right. So, if you look at this figure, basically this is your sigma 3, right. So, you are allowing the new sigma 3, that is nothing but, so this point is basically sigma 3 plus delta sigma 3, and due to that you are getting some pore water pressure generation delta UC. Okay. Now, I mean once you do this, so minor principal effective stress is becoming, that is your total, what is this? This is your total minor principal stress. So, total minor principal stress minus your delta UC minus delta UDF will be giving you the effective minor principal stress, right. So, that is becoming sigma 3 prime. Similarly, the major principal effective stress, is sigma 3 plus delta sigma 3, that is the cell pressure, all round cell pressure, plus the deviatoric stress sigma dF at failure, minus the pore water pressure, that is delta UC, which is happening during the increase of delta sigma 3, and delta UDF, that is the pore water pressure which is happening during shearing. So, again these two are same, right. So, sigma 3 plus delta sigma dF minus UDF, which is equal to this, what is this? This is your sigma 1. So, sigma 1 minus delta UDF, which is nothing but sigma 1 prime. So, you are getting this. So, now ultimately you are here, now you are our effective major principal stress is sigma 1 prime. So, whatever you do, whatever you are doing, I mean by increasing the cell pressure, you are getting two different total stress Mohr circles, right, P and R, but for both the cases your effective stress Mohr circle is same, that is Q, right. That I meant to say at the starting. That means, that is the reason, that is why you are getting the same. Thus, the effective Mohr circle will still be Q, because strength is a function of effective stress. Okay. No matter whatever you do, your total stress Mohr circle will be, n number of confining pressure you change, n number of total stress Mohr circle you will be getting, but your effective stress Mohr circle will be unique. So, your effective stress Mohr circle will be more logical to consider during design. So, note that the dimension of P, Q, R are all the same. So, dimensions are not different, right. So, the radius of the Mohr circle P, radius of the Mohr circle Q, radius of the Mohr circle R, all are same. Okay. So, therefore, they are remaining same, only thing is that you are getting different total stress Mohr cycles, and for that corresponding unique effective stress Mohr cycles will be unique. Okay. Thank you very much. So, I will stop here today. So, in the next lecture we will be considering different kinds of tests and different kinds of issues related to the shear strength chapter. Thank you very much.